Hello, this is section 5.3, Polynomial Multiplication. Part 1, Defining and Describing Polynomials. A polynomial is an expression of the form an x to the n plus an minus 1 x to the n minus 1 plus a1 x to the 1 plus a0, where x is the variable, the ak are coefficients, and the decreasing exponents are whole numbers. So that's important because if you have fractions or negative numbers, it's not a polynomial anymore. So assuming that an is not equal to 0, then the largest exponent, n, is called the polynomial's degree. Moreover, we call an x to the n the leading term, which makes an, since an is a coefficient, the leading coefficient. So in other words, if you're asked for the leading coefficient, it's only the number in front of the variable. If you're asked for the leading term, it's the number and the variable. Lastly, we call the a naught the constant term, since it has no variable. Example 1, identify the degree, leading coefficient, and constant term of the polynomial. So the degree is 5, the leading coefficient is 15, and the constant term is -1. Polynomial varieties and names. A polynomial with only one term is a monomial. With two terms is called a binomial, and with three terms is a trinomial. If it has more than three terms, we usually just call it a n-term polynomial. So if it has 5 terms, we'll just say it's a 5-term polynomial. A polynomial of degree 0 is called constant. Of degree 1 is called linear. Of degree 2 is called quadratic. Of degree 3 is called cubic. If it's higher than degree 3, we'll usually just call it the nth degree polynomial. For example, if it's degree 7th, we'll just say it's the 7th degree polynomial. Part 2, multiplying polynomials. Recall, the distributive property says that you can distribute a product over a sum. That is, for any real numbers s, r, and t, we have s times r plus t is equal to s times r plus s times t. But you can also flip that around and say that r plus t times s would equal r times s plus t times s. So it does not matter on which side of the parentheses that monomial is. To multiply a monomial with a polynomial, you use the distribution property once. When multiplying two polynomials, you must use both left and right forms of the distribution property. Example 2. Multiply the following polynomials and write the result in standard form. So when you're multiplying polynomials, you're going to just want to use the distribution property. Now, some of you may have learned the acronym FOIL in high school, and it only works in specific cases, and I see students use it incorrectly more often than they use it correctly. So I recommend avoiding that acronym. So now I'm going to distribute 2x squared times x cubed is 2x to the 5th. 2x squared times negative 3x is negative 6x cubed. and 2x squared times 1 is 2x squared. Part B. In order to use both distribution properties, that's equivalent to just saying take everything in the left multiplied by everything in the right. So I'm going to start off with 3x. So I need to take 3x times 2x, which is 6x squared, and 3x times negative 5, which is negative 15x. Then I need to take the negative 4 times 2x, which is negative 8x, and the negative 4 times negative 5, which is positive 20. And now I just need to combine like terms, 6x squared minus 23x plus 20. And finally, part C, we have 3x minus 1 times 4x squared plus 3x minus 6. So 3x times 4x squared is 12x cubed. 3x times 3x is 9x squared. And then 3x times negative 6 is negative 18x. The negative 1 times 4x squared is negative 4x squared. Negative 1 times 3x is negative 3x. And negative 1 times negative 6 is positive 6. And again, I need to combine like terms, so we get 12x cubed plus 5x squared minus 21x plus 6 as our final answer. Part 3, Special Products. Multiplying the following expressions, then simplify to complete the following special product forms. Square of a binomial. So when you have u plus v squared, that actually becomes u squared plus 2uv plus v squared, not u squared plus v squared, which is the most common mistake in this class. They want to distribute the exponent, but you cannot distribute an exponent over a plus sign. Next, when you have u minus v squared, that is u squared minus 2uv plus v squared. And last but not least, when you have u plus v times u minus v, well, let's just use our distributive property. We get u squared minus uv plus uv minus v squared. Well, the UVs cancel out, so that means whenever you have two binomials with an opposite sign multiplied by each other, it becomes a difference of squares. While familiarity with these formulas is useful, we can always just multiply things out too. Example 3. Multiply and write the result in standard form. A. 2x plus 3 times 2x minus 3. So this is a sum and difference product. So that means it's going to be 2x squared minus 3 squared according to the u squared minus v squared formula. And simplifying this, we get 4x squared minus 9. X minus 3 squared becomes x squared and then minus double u times v. So x times 3 and double that. So 2 times 3x. And then plus 3 squared, which is x squared minus 6x plus 9. And 3x plus 1 squared using the formula above becomes 3x squared plus 2 times 3x times 1, and then plus 1 squared, which is 9x squared plus 6x plus 1. And that is it for section 5.3.